Hello, my hosts, and welcome to another coding stream. Today, we are going to continue to be working on rewrites and redesigns of our the way we handle Bezier curves. So let's get into it and talk about what we will be doing. Let me pull my wings in so take up less of the space on the screen. So we have our 2D curve here. And I've realized I need a function that allows me to, for a 2D curve, transform it from a parametric curve to basically a functional curve. Now I'm going to check something. Going to look up some things here. Tension between line and a Bezier curve. Stack exchange. If one end of control per simple one. Roughly the same. X, Y, Z in vector form. Blah, blah, blah. The form, up to the previous one. Need to solve for T values, 3 of them. You'll probably want to ignore it. I'd pass through either the start point or the end point of the Bezier curve, so T equals 0, 1. Solution of the cubic equation, which makes it simpler. Analytic. Solve. What can you do for me? I don't know what you can do for me. I'm just going to, hold on. Chat should be visible. Isn't chat visible? There, switched on chat. I'm just looking up the way of calculating the intersection between a cubic Bezier curve and a line segment. Cubic dip. Right. Arch line in implicit form. Yeah. Yummy birds likes you. So you do. So I'll do you a favour. Okay. Well, keeping me company and perhaps subscribing would always be appreciated. truly a really... Da-da-da. Control points, basic debt. Right. I think I'll need to do some more research on that offline. But thankfully, the good thing is I can just abstract that away. And we can have a function which is called float on curve. It's going to take a spline, a float, and return a float. And we're going to write some documentation for this. On curve finds a returns the y coordinate for an x value where value, assuming that the curve always increases in x direction to do write this as a test or oh, I am a fooccubus, so a type of incubus slash succubus. And I am programming in Haskell on an animation program. Write this as a test. To do write code, enforce the precondition. Copy. Gonna go spline. Oh, sorry. Let's say equal undefined. And equal undefined is handy because it allows us to what are saying? Having an undefined point allows us to just say we'll do that later. So it's to-do code. While we're up here, let's copy this. Go down there. And we go D2 on curve. D2 on curve. D2 on curve. Going to take a float. Turns the x comma y coordinate for a z value. So you from Davy Jones? I suppose that's a fair assumption. Import qualified spline.d2 as d2. We go d2 dot point. There. Hi, Slim. Good to see you as well. I have been pretty good. Let's load up spline.d3. Let's see if it compiles. Spline.d2 does not export point. Okay. No, it doesn't. It should, though. Point. And like that. Point on curve and export float on curve. And then we do the same thing in 3D space. Copy that. Spline and point. D2 on curve. There we go. Right. So that works. And we'll close those off. Start looking at how we're going to do this shape thing. Okay. Boundary, path, path, path. Path we said was context to point. We've got shape, which is boundary. So and on path. I'm just trying to remember all the stuff we did for my brain. All right. Here we are. The current time. We will remove this. Render point on path. So we've got a boundary and a context. We want to give it a point. So we don't actually want a boundary here. Sorry about me sort of just talking to myself. This is the outside edge of a shape. This is a path. So that should loop. Circle. I'm currently writing this on Windows as the platform, because it's the easiest thing I've got to program with. If I was doing sort of like industrial type programming, so back-end server type programming, then I'd be using a Unix box, which is far better for that particular sort of server type stuff. All right. There. So I'm there. So I write on Windows? Yes, I do. Right. There, the shape tree. So this is a Bezier curve around a particular area of space at a particular time. And that goes like that. Okay. What I'm looking for is to work out how so render point on path takes a boundary, turns why? But that's not what a path is. Let's hold on. Render point on path. Where are we? Render point. I'm going to do a little bit of searching here. Render point on path. Render point, st point to path. What is st point? It's st path. Okay. Let's split the screen so I can see a little bit more info. It's how do we split the screen up between two screens? Keep forgetting stuff. View. layout. Ah, there it is. Split up. Save that. ST screen. It's for the shape tree. Right there. And I managed to do shape tree. Shape tree. Param path path. Path is line curve curve. Okay, that is the problem. That should not be a path. That value because that is going into okay data. Oh, what are we going to call that? So a path is a line at a point in time along the 2D plane. What are we going to call this concept? This is the hardest part in blank is a also this has to be a curve. It's a curve through 3D space time where each point at a particular in time is a particular at a particular time is a unique 2D coordinate. Is a 2D coordinate rather than a unique one. All right. What would we call such things? Maybe that should be a path. Okay. Let's go synonyms for path. Footpath, track, trail, ride, lane, walk. Right away. A trace might be a route. Course of action. Plan, tactic, strategy, trajectories. Okay, let's call this one a route. That would make more sense. Call this a route. And that will be D3 dot D was be D3 curve. Oh, save. You go over here, D3, where are you? D3 dot spline. Import line dot 3 as D3. Perfect. That makes a sort of sense. I say, and suddenly lose confidence if it makes sense or not. That's actually, we'll call that spline, unless we've got does that work? Load shape dot 3. Hi, possible cultist. Qualified name in binding position. Yep, that would help if I saved things. Endpoint. All right. 38. D3 point or shape tree point. Obviously, it refers to shape tree point. Qualified. There. That fixes that up. Fine, not used. Yep, we're aware of that. So, change that from point to route. Route. And I think that will work. I'll change the ordering as well. That fixes that up. Problem with exploratory programming is it's very easy to get lost. Because you're doing it without a map, basically. So move into shape, back in shape func. That's going to die horribly. Yep, excellent. That's exactly what we want. Shape func. $63. Oh, that's weird. It's a parse error. Why are we getting a parse error here? That's what I was more expecting. 179. How are you going, Possible Cultist? Because I am going pretty well. There we go. 179. That highlighting looks wrong. Okay. Render point. So that will be... We'll stick tree up here. No, I want tree on that screen. There we go. So ST point is now ST route. Oh no, right, ST point's still the same. It's amazingly why is that strangely highlighted? Oh, I did a search for it. Let's remove the search. Now it doesn't get highlighted. 179. So you are no longer path. You are route. Route. And that's 2D spline. So if we go ST dot spline like that. We remove that. Got your context. Got your spline. D3. D2 on curve is what we do want. So we're going to have to import this one. Import qualified spline.d3 as D3. Things seem to be becoming clearer now. Where is my code that I got lost in before? .183, that's probably where it is. Yeah. So we take spline. We break out the context. Time context. There we go. Render. Oh. D3 dot. Think D2 on curve. D2 on curve. Spline, that will be a thing, so that will return a D2 point. So call this D2 equals that. Say let D2 equal there. In. So this is returning a path. Can I just hover this over and have the definition pop up? No, that would be too easy. The path in here is context to point. So I want point. So its point is float to float. On 8.3, where are we? Right. So actually we can do a use D3 point y in point xy. I think that makes sense for what we will be doing. Let's save that and load it up. Shape dot func. It's failed. How's it failed? Shape tree does not exploit spline. Ah, yeah, it's not shape tree spline. It is. Oh, it is shape tree spline. So we've got to have route like that. Could not match. 2, 5, 6. Two, 5, 6. Oh, we don't need that anymore. Hold on, that's... Why is that indented so much? Everything's weirdly indented. How do I fix that? I would know how to do it if it was in... I'll fix that later. No, I can't fix that later now that I've got the problem. I've got to fix it everywhere. Let's see. We are using Visual Studio Code. Remove one level of indent. Okay. Oh, really? New versions of Control. Okay, let's try that. Select all of this. Control. There, okay, that fixed it. Right, let's try that now. Parse error on input. That's 21. Oh, parse error, okay. Save it before we do anything. Okay. Two nine. Render point on path. Render the ST point into a boundary. I'm not sure what to do here. But I'm noticing that we are coming up to the end of our streaming time. So I will look into that a little bit deeper. Let's switch that over. Studio mode. Yep. Let's go back to my main room. Thank you, everybody who is watching. We had a moderately productive scene today. We've gone and broken the code even more, which is fairly typical for this stage in development. But we will have to be fixing everything up in our next stream when we do a next programming stream tomorrow. I'm going to check my schedule and see what we'll be doing. You'd think I'd get used to my schedule fully by now. Let's have a look what we will be doing. All right. I think it's going to be it's going to be Factorio tomorrow. So look forward to that. As always, thank you for watching, and I hope to see you later. Goodbye.